Hello students, welcome to the channel of Vedant classes. Okay, so in this lecture we'll see the sign convention for the spherical mirror first. So let's see sign convention for spherical mirror. Okay, now see how we can consider the sign convention for the spherical mirror. Okay, now consider a Cartesian coordinate system. Okay, consider the Cartesian coordinate system like this. This is x dash, this is y, and this is y dash. Okay, now at the origin, consider you are having your pole of the mirror. So mirror, let's consider the concave mirror like this. So pole of concave mirror is at the origin of this Cartesian coordinate system. Okay, so now this axis is positive x-axis, this is negative x-axis, this is positive y-axis, and this is negative y-axis. Now what you need to do, you just need to simply, okay, if anything is there left of pole, okay, you just need to consider the distance. If distance is left of pole, then you need to consider it as negative, okay, in this side, and if it is right of pole, then you need to consider it as positive. Okay, for height, if it is, you can say, above the principal axis, if anything there above principal axis, then you need to consider it as positive. Anything above the principal axis means in this direction, height. Okay, if anything is there below principal axis, then it will be considered as negative. Okay, so these are the simple sign conventions, okay, that I used to follow. So this is the very simple technique to apply. Now let's see one example to clear the concept more. Let's consider any case. We are having a, suppose we are having a concave mirror like this, and this is the principal axis, this is our pole. Okay, let's say this is focus and this is center of curvature. Now let's say if we place an object here beyond C, okay, so we know that we'll get image somewhere between C and F. So consider the parallel incident ray, so it will pass through the principal focus parallel to the principal axis, then it will pass through principal focus. Now consider the another ray which is passing through the center of curvature. So consider another ray which is passing through center of curvature like this. Then it will reflect back on the same path. Okay, you can also consider the light ray from F. So this will be, if object is AB, then here you will get an image A dash B dash. Okay, so now let's see how we can apply the sign convention in this. Okay, so now let's see. This is focal length F from F to P. This is radius of curvature from C to P. Okay, this is our object distance U. This is our image distance, that is V. We need to consider it from here. Okay, here, then C, and this will be your F. Okay, now you just need to consider the height of object, that is H, and height of image you can consider H dash, let's say H dash. Okay, so now see, let's start with object distance, that will be equal to U. then image distance, that will be equal to V, then focal length, that will be equal to F, then radius of curvature, that will be equal to R, then object height, that will be equal to H, and image height, that will be equal to H dash. Now see how we can apply the sign for this. Okay, so as you can see from this, all four are left of pole, you can see clearly. So in this case this all will be negative. Okay, as if this all are just the left of pole. So if left of pole, then you have to consider it as negative. Now you can see that height of object is above the principal axis. Okay, this is your principal axis and object is above the principal axis. So H is positive. You can see H dash is below the principal axis, so this will be negative. So this is how you can apply the sign conventions. Okay, so just follow the rules. Okay, these rules you can follow and just apply the sign conventions. Okay, now let's mention few important points. Now see, object distance is always, you need to take negative, because object is always placed on the left in front of the mirror, so it will be always there in left side of the pole. Then you need to take object height, always positive, because it will be upright, it will always be in the upright position, so you just need to consider the object height always positive. Okay, then let's talk about the focal length and radius of curvature. Okay, so for the two different mirrors, for concave mirror and for the convex mirror, for two different mirror, let's see the different cases. Now see, in the case of concave mirror, the mirror is like this, and you can see that focus is here and pole is here. So you can see that focal length is in the left side, so you need to consider F negative and R also negative in this case. Now in case of convex mirror, you can see that here pole will be there and focus will be there. Virtual focus it is having, that we have discussed, right? So it is there in the right part. So focal length for the convex mirror is always positive and radius of curvature will also be positive, as R equal to 2F. Okay, so as R equal to 2F, if F will be negative, then R will be negative, and if F is positive, then R is also positive. Okay, so this is the important notes that one should remember for the sign convention. Okay, so now let's see the most important formula to solve the sum, and that is mirror formula. Okay, so let's write the formula here. Mirror formula. Okay, so mirror formula is written as it is. Now see, I'm writing the definition. Formula which gives the relation between focal length, then object distance and image distance for spherical mirrors. Spherical mirror is called mirror formula. So this is the definition for the mirror formula. So it gives the relation between focal length, object distance and image distance. Okay, so let's see the equation. So the formula is 1 by f is equal to 1 by v plus 1 by u. So this is the mirror formula, okay, where you can see f is equal to focal length, okay, then u is equal to object distance and v is equal to image distance. So this is very important formula, okay. Use according to the sign convention. Whenever you will use this formula, just consider the sign conventions, okay. Use with necessary sign conventions. Use with necessary sign convention, okay. When we solve the sums, we will see how to use the sign conventions using this formula, okay. Now let's see the next topic, that is of magnification. Magnification, okay, it is noted as small m. Magnification is noted as small m. Now what is magnification? Let's write its definition. The ratio of image height to that of object height is called magnification. So it simply just tells you that how much time the image is getting larger as compared to the object, okay. So height of it is just the ratio of image height to that of the object height. So let's consider h is equal to object height and h dash h image height, okay. So magnification m will be equal to image height upon object height. So we can write m is equal to minus v by u. Sorry, m is equal to h dash upon h, okay. Also we are having one more relation, m is equal to minus v by u, okay. So you can compare it. See, these are the formulas you don't need to derive, okay. You just need to remember this formula to calculate the sums. So m is equal to minus v by u. This is for the spherical mirror, okay. Remember this formula for spherical mirror. It is very important relation. Also one more relation that we already seen, r is equal to 2f, okay. So here few formulas are there. One is mirror formula, then another is formula of the magnification, then third is r equal to 2f. So just remember this formula, it will help you to solve the numericals. Okay, now let's see few most IMP points related to the magnification, okay. So these are the most IMP notes, okay. It is a kind of golden notes for you, okay. So now see, the magnification is expressed as like this, okay. First you need to put a sign, either positive or negative, and here you need to put a magnitude, that is its value, okay. So how we can identify the type of image? So see, if magnification is positive, then it will have virtual image, then it will form a virtual image if it is positive. If the value of magnification is negative, then it will form a real image, okay. Now let's talk about the magnitude. If the value of magnification is greater than 1, okay, then it will form an enlarged image, okay. It will form a magnified image. If magnification is equal to 1, then it will form the image of same size. If the value of magnification is less than 1, then it will form diminished image. So these are the most IMP key points. Okay, you should remember. It will be very helpful for you to solve the short questions. Okay, so now let's see that important notes for the mirrors. Let's consider the important notes for mirrors. So first of all, let's talk about the plane mirror. Okay, so plane mirror. In plane mirror, it will always form. It always form. It always form virtual and erect image. Okay, it always form virtual and erect image. Also, always form. It always form. You can say image of same height. Okay. In the properties of plane mirror, we have seen that height of object will always be equal to height of image. Okay, so image height and object height will always be same. So here it will form an image of same size. Okay, same size as that of object. Okay, image will be of same size as that of object. So these are the important points one should remember for the plane mirror. Okay, so now let's see the next keynotes for the concave mirror. Now see, for the in case of concave mirror, it forms both type of image, real image, okay, real and you can say inverted image, and it also forms virtual and erect image. Okay, in sixth case, it forms virtual and erect image when object is placed between pole and focus, and in rest of the 5 cases it forms real and inverted image. Okay, that we have seen in the image formation. Now it forms you can say diminished image. Okay, diminished image. It forms image of same size. It also forms magnified image. Okay, magnified, or you can say enlarged image. So it also forms all the 3 types of image. So this is the data for the concave mirror. This is the observation we get for the concave mirror. Then for the convex mirror, now see, convex mirror always forms virtual and erect image just like plane mirror. Okay, also it always forms diminished image. Okay, it always forms diminished image. So these 2 points we are already noted in case while showing the image formation for the convex mirror. So these are very important points one should remember to clear all the short questions, and it will also help you to solve the numericals. Okay, so take a screenshot for this one. Now let's see few examples. Okay, now if the magnification is given like this, let m is equal to minus 2.5. Okay, so how we can identify? Yes, there is a negative sign, so it is a real image. Now see, 2.5 is greater than 1, so it is enlarged image. As it is real image, right, so it will be inverted. Okay, now you can see real image will always be formed in only in the case of concave mirror. These two will never form a real image. So if you want to identify the type of mirror, you can easily tell it is a concave mirror, right? Now let's take another example. M is equal to Okay, m is equal to plus let's say 0.33. Okay, so plus shows that it is, this plus shows that it is virtual and erect image. Then 0.33, which is less than 1, so it is, you can say, diminished image. Now if you want to identify the type of mirror, okay, so see, plane mirror forms virtual erect and same size image. It forms virtual erect and magnified image, because in sixth case, if you remember, it forms virtual erect and magnified image. So in the case of convex mirror, it forms virtual erect image with diminished image. Okay, so this is convex mirror. Okay, let's consider one more example. M is equal to plus 1.0. Okay, this is value of magnification. So here plus shows it is virtual and erect image. Then here it is 1, so same size image. Okay, here value of magnification is 1. So if it is 1, then it will be same size image. Now see, virtual erect and same size, so it will be a plane mirror. If we want to write the type of mirror, then it will be a plane mirror. So this is all about the sign conventions, mirror formula, magnification, and the most important notes regarding the magnification. So take a screenshot of this. Okay, so that's it from this lecture. Please like, subscribe, and share the channel if you are finding it helpful, enjoying learning over here. Okay, so please stay tuned for the more important lectures ahead. Okay, so keep working hard, enjoy the physics. Thanks a lot.